Hi everyone. This week we are going to be going over the first part of chapter 8 in your book, which is going to be a reintroduction to JavaScript. We went over it a little bit in our first class. We're going to be digging quite a bit deeper in this class. So, in this week, some of it you're going to learn this week, some of it you're going to learn next week, and I will update the slides. I'll update it right now. So, in this chapter, we are going to learn about JavaScript's role in contemporary web development. So that means how it's used today. How to add JavaScript code to your web pages, so how to actually use it. The main programming constructs of the language, with the exception of objects. So we are going to be going over arrays this week, but we are going to be going over objects a little bit more next week. And then finally, we're going to end with functions and how they work in JavaScript, partly. So there is quite a bit to functions. So objects and the more advanced uses of functions are going to be week 6. In fact, let's do this. There we go. We're doing it live. Okay. Let's start with what JavaScript is and what it can do. JavaScript is object-oriented and dynamically typed, and it's a scripting language. So object-oriented means that the main pieces that you use are objects. Dynamically typed means that your variables do not necessarily have to be explicitly declared, and we'll go over that. And then scripting language just means that it runs scripts, right? So it's primarily a client-side scripting language. What that means is that it is not run on the server, so it saves a lot of overhead in terms of processing power. And it means that your end users need to have JavaScript enabled on their machines, otherwise those scripts will never run because it's basically running on their machine. Variables, this goes back to the object-oriented. Variables are objects, and that they have properties and methods. We'll go over that a little bit more when we go over functions. And then if you are familiar with Java, C#, C++, in those, functions are not objects. They are their own separate things. But in JavaScript, functions are also objects. So that means that they have properties and methods as well. So this is the explanation of what dynamically typed means, in that variables can be converted from one data type to another really easily. If you've worked in C# or Java or C++, you have to explicitly declare those variable types as like an integer or a float, which is like a floating point number, or a string, and then you have to explicitly convert those by calling things like toString or toInt, which are different methods to do that. Okay, so this is just a brief explanation of what we mean by client-side scripting. This should look familiar from last term. Basically what happens is, this is the pathway, right? So you're loading up a web page, your computer makes a request to the server sends back the HTML first, and then, so this might actually be like a little bit of a misnomer here, because since it's kind of top down, it will send back the HTML, but if you have a JavaScript like the first thing in your header, it's going to stop until it stops that JavaScript for rendering. But basically, don't do that. The proper way is to have it either like further down in your header, or even you can do it in the body or the footer. and that defers loading a little bit, which means that the loading, it takes place last, so that your users still get most of your page content. And if there's an error with your JavaScript, it will stop everything from loading. But if you put that last, they're still going to get most of your page. But anyways, I digress. User flow. Request is made. Hits the server. Server sends back the HTML content. Hits the request for the JavaScript file. JavaScript file is sent from the server. JavaScript is then parsed, which means like read, and then executed by the browser. So not by the server, but by your user's computer, which is why it's important to understand that if you put JavaScript on there, your users have to have JavaScript enabled. 99.999% of your users are going to have JavaScript enabled, but it's a good idea to have a fallback. And then finally, your browser is going to display the page based on the JavaScript alterations of the HTML content. Because the function of JavaScript, not the object function, but the reason that we use JavaScript is to alter the HTML of the page. Okay. So what are the advantages of client-side scripting? Well, we kind of already went over these, so I'm just going to briefly do it. It's offloading from the server to the client machines, which means that doing stuff takes a lot on your server. So anything that you can defer to client machines or offload to another service, like why I prefer hosting videos on YouTube versus hosting videos on my servers, because it takes that weight off of the server response time. Browsers can respond more rapidly to user events than requesting the server. Basically, if you are not using a client-side script and you are using a server-side script, every time a client interacts with that, it has to send it back to the server and get a response back. That is going to take far more time, right? And then finally, that JavaScript can interact with the HTML in a way that server requests can't. So this is going to be more like software than just regular HTML. And it's also allowing you to alter things past runtime, which basically means like once the page is loaded, it does not necessarily have to reload the page to alter it with JavaScript. If you're using things like C#, like if you're doing a .NET page, it does have to reload that page every time to get those alterations, unless you explicitly tell it not to, but still not the most optimal user experience. Okay. Now, what are the disadvantages? Well, let me scooch this up a little bit because it's bugging me. There we go. So, there's no, like I said, there's no guarantee that the person on the other end of their computer is using JavaScript or has it enabled. It can also be, it can get really complicated really fast. So, making sure that you're using proper like indentation and commenting and other notations, so that if you get somebody's legacy code, hopefully they've done that, or you're setting the next person up for success. I also apologize, it's kind of warm up here, so you may hear my air conditioner kicking on. Hopefully it's not too distracting. Finally, it's not fault tolerant. What that means is, like I was mentioning before, if you have an error in your JavaScript, it's going to stop doing what it's doing. And it's not going to do anything past that. So once it hits that error, your page is done. And whatever's loaded there is loaded there. And then also, something to be aware of, like CSS3, although JavaScript is supported basically by every browser out there, the newer features and APIs and libraries, which we're going to be going over in later weeks, are not necessarily supported by all browsers. So it's really important to, if you're using any of the newer like APIs or libraries or anything like that to check the browser compatibility on them to make sure that all of your users are seeing the same thing. Cool. So let's take a little bit of a history lesson here. JavaScript is pretty old. JavaScript was introduced by Netscape and Netscape Navigator in 1996. Netscape Navigator is what ended up becoming Internet Explorer, which is now Edge. So yeah, like way old, but still in use. Then Netscape submitted it to basically a like an international cohort in 1997, and then it's just been building and building and building. The latest edition is the 10th edition, which is EC 11 or EC 2020, and I know that they're working on an 11th. Okay, so I showed you the basic workflow of a JavaScript request. This is JavaScript 2.0, which is a little bit more than the basic, but still has the basic workflow in it. Think of it as JavaScript Plus. So you have the fifth, 1 through 5th, first through 5th steps are the same. You know, request is made, server sends the HTML, HTML requests the JavaScript, JavaScript is sent. And then here's where it diverges. So web APIs are basically little blocks of code that you can load asynchronously, which means that that is outside of the normal flow of loading. So, you know, if you think about it in steps like this, 1, 2, 3, 4, 5, asynchronous can happen anywhere in that. And we usually use it to defer, again, put off loading really heavy assets until the end to make things go faster. So, your JavaScript makes a request for a web API. Web API grabs that from their server. Web API is returned in JSON format. We will be going over JSON quite a bit. It's really, really cool. And then finally, the end step is that the web API and the server are pretty much continuously talking. So the page continuously updates based on user interactions and data. Think of it like, I hate to use Twitter as an example, but Twitter uses that kind of continuous API where it's constantly sending back and forth data to update so that you get the most recent posts. Okay, so how do we use JavaScript in software development today, right? Well, there are so many ways. So JavaScript does not work on just the browser. It works on so many things. You can create software, basically experiences within the browser. You can create browser extensions. You can use things like React or Ember, which we will be going over React in week 9 and 10, to make non-browser applications. So you can make apps using JavaScript. It's also bundled in other applications. You can make games with it. You can make virtual reality experiences with it. You can make virtual tours with it. You can create interactive maps. You can use it on server for development environments like Node. We will be so briefly touching on Node, but not really. And then for databases who don't use SQL or SQL, which is structured query language, you can use JavaScript to ask questions to those databases. It's also the control language for what's called Internet of Things devices. So your smart cameras, your smart fridge, your smart washers, those all are based on JavaScript. And then now a lot of embedded systems, so like the systems that are embedded on microchips, use JavaScript. OpenOffice and Adobe Creative Suite use it. It's basically become the backbone of a lot of applications outside and inside of the browser. So now that we have learned a little bit more about what JavaScript is and where it came from, let's learn a little bit more about how you use it. So JavaScript, just like CSS, can be inline, which means that when you're typing out your HTML, you can add JavaScript in the tags of your HTML. Please only use this scarcely. It can be embedded, which is just like using the style tags at the top of your head element or in your body or whatever of your HTML. And then you can also external, which we will be, for our lab, doing external. Just because the files get so beefy, it's preferred to do it external unless you have like a 3 or 5 line JavaScript. Then you can put it in the header. But if you have everything in an external file, you know where to go to update it. So let's see an example of this. Come on. Okay. So, embedded JavaScript is at the top, and then we have an external, and then we have an inline. So, from the top down, we have our opening of our HTML, we have our head area, we've got our type. I beg your unbelievable pardon. There we go. And then we have a opening script tag. This is how you write a comment in JavaScript. And then your script content. And what alert is it makes a pop-up window. Oh, stop it. There you go. It makes a pop-up window. And that pop-up window, whatever you want it to say, goes inside the alert. And then you close your script tag. So that's embedded. You have an opening and a closing. For external, it's just like your style sheets. Well, not exactly like, but it's very close. So instead of having your reference, you have a script source. So script, and then your source points to where the file lives, what type of file it is, .js, and then close your script. Okay? And then this is inline. So we have an A tag here, so it's a link, and it's saying, when you click that link, so that's what your href is saying, do this when I click this link. And then for this, it's saying JavaScript open window. Basically, what that's saying is when you click that link, you're going to do a JavaScript thing, and that thing is called open window. And then the last one is also inline. It's so using onClick is pretty normal, but normally you call a function in a embedded JavaScript file. Okay, so in this one you're using onClick. So when this button is clicked, it pops up a window, because remember that's what alert does, asking, are you sure? And then another example of embedded down here. Just another alert saying hello world. Okay. So here are the reasons that people may not want to use JavaScript. And we'll also talk about an edge case as well. So some reason that users may not want to use JavaScript is search engines don't want to implement JavaScript. They want to ignore that. Browser extensions, though made of JavaScript, may conflict with JavaScript on your page. Text browsers, so things that like search engine robots.txt, they do what's called scraping, which means they go through every page of your site, grab the content, and then parse it, piece it up so that your site can be shown on search engines, or have your content stolen. You got to deal with it though. And then accessible browsers. So to make things accessible, you got to be really careful about how you're using JavaScript. There's a way to do that. If you use the no script element, so before we had the script, if you use no script, it's only going to be shown to people who don't have JavaScript enabled. So there's still, this is your fallback, right? No script also helps if you have multiple versions of JavaScript. So sometimes if you're using a content management system, the content management system requires one version of JavaScript, or more likely jQuery, which is a library. And then you need to use another version. So the no script also helps you use basically two different versions without conflict. Okay. So now we're going to start getting into what the pieces of JavaScript actually mean. So it's going to be a little bit abstract, but when we start going through your lab, you're going to want to reference this to be able to do your lab. Okay, so variables, right? Variable is a thing that holds another thing. It's basically a box. Variables in JavaScript are dynamically or weakly typed, like we talked about before, which means that you don't have to explicitly say that it is a number or a string, which is text or whatever. You don't have to declare it before you use it. And what that means is that sometimes in other programming languages, before you are able to use a variable, you have to declare the variable, which is what the first example is, right? It's declaring a variable named ABC without actually setting it to anything. And you can do that. That's really, it's a good way to do it if you're going to have to change what that variable is equal to multiple times. And you want to be able to reset it back to like a default. But you don't have to declare it before you use it. And then to declare it in JavaScript, you either use var, which is variable. The second one is for constant, or the third one is for let. These are kind of explained a little bit more in your book on table 8.1, when to use those. But basically, use a constant when you are going to set a thing and then not change that thing. Use a variable when you need to use it globally. So if you have several functions, if you need the variable to be present in several different things, use variable or var. And then let, just use within like a function, basically. It's a lot easier to swap. And then once you declare the variable, you have to assign it. And that's just a fancy way of saying set it equal to something, right? So yeah, variable or let var const name of your variable equals whatever is equal to semicolon. So if we look at the examples here, the first one, let ABC, is just setting a variable, or saying, hey, there's going to be a variable called ABC. Right now it's not set to anything. The next one down is saying let this variable called foo that we are defining at that moment be equal to 0. And remember, all of these have to be ended with a semicolon. That's how you end a line in JavaScript or a statement. Now, the next one down is, since you've already set foo to 0, it's just changing what it's set to. But if you haven't created foo, so if you haven't declared it first, it's going to get really confused. So the first time you use a variable, you have to either have that var, const, or let in there, right? But once you have it, you can change it unless it's a constant anytime. So the next one is setting foo to 4. In JavaScript, white space doesn't matter. You can have extra spaces in there. It's all good. And then the last one, so we change it from a 0 to a 4. Those are both numbers or integers. The last one, we set foo to hello. Big thing to notice here is that we're changing it from a number to a string. You don't have to do anything to convert it. That's fine. And it can also not be on the same line. They've hit enter between, and it still works. The things that it is looking for are what is to the left of that equal sign, what is to the right of it, and then cutting it off with a semicolon. Okay. Pardon me. These are the ways that you can output in JavaScript. Output is different than altering HTML. Output is actually putting something out there. Okay? So an alert is what I said, pop-up window. It's going to have an OK there. The way that the pop-up looks is dependent upon by the browser. You can add a little bit of styling to it, but it's always going to be dependent on the browser. A prompt is a pop-up window with an input field. So basically something you can type in there. And then a confirm is basically going to end up being like a Boolean, a yes-no answer. But it's a pop-up that displays a question, and then you're going to have an OK and a cancel. So it's like your OK is the yes, the cancel is the no. The other ones are document write, which means that it is writing directly to the HTML content. So there are programs that basically use this document write to build the HTML of the web page dynamically on page load. So they are writing their whole web page through JavaScript on load. And then console log, when you bring up the inspector with either F12 or right click and inspect, you can display content there. So when you open that up, it's going to automatically go to elements. Up at the top, it's got those tags. If you go over one that's console, you can see error messages there, and you can also see any console logs. So you can use that for debugging, which is basically looking for errors and stuff, by putting console logs in there to say, okay, I've gotten to this point, I'm going to test it, have it write something, and then see if it goes on from that. So we're going to learn about the DOM model, which is document model object, or document object model method. And that's basically how the page loads from start to finish. You can use document write to add HTML into your JavaScript. but that happens like post rendering of the page. So you basically want to do it earlier, but we're going to be going over that in 2 weeks. So week 7. So right now it's fine to use it. Okay. JavaScript has 2 data types, okay? Reference types, which are objects. So we're just going to call them objects. And then primitive types. So primitive types, we're going to go over on the next slide. The thing about JavaScript is that you can use primitives as objects, so don't get too hung up on it. Just know that there are 2 different types. Okay, so these are what we were talking, or I was talking about with the prompt of a Boolean. Boolean is the simplest kind of value you can get. It's either a yes or a no, a 1 or a 0. True, false, that's a Boolean. A number is a number. It's got like, you can use decimals in it. That's what the double precision 64-bit floating point value is. If you've done any C# or C++ or anything like that, you don't need to use int or float. You can instead just use number. A string is a sequence of characters with you have to surround a string by either a single or a double quote so that it knows that, hey, these are characters. Because otherwise the way that it works is every letter on your keyboard has a storage space somewhere in your memory. And if you are not saying that, hey, these are text characters as a string, then it's going to reference that memory area instead. Pardon me, just 1 minute. Allergies, man. Okay. Null only means null. It means it has no value. You can't have any other values if you're setting it to a null. Undefined only has 1 value, undefined. When you define a variable and you don't set it to something, so in that first one where it had let ABC and then the semicolon, right now it's undefined. Because you haven't set it to anything. And then undefined it's different than null. Null means nothing. It doesn't exist. Never will exist. Undefined means that there's something there, but it's not set to something. And then the newer ones are symbols. And you can set those as a key value, which is used more for database stuff, kind of outside the scope of this class. But just know that symbols exist. Okay, so now we're going to look at what I was talking about versus, like, with the difference between a primitive and then an object. Or sorry, primitive versus a reference type. Remember, a reference is just an object. Yeah. So, up at the top here, we have some variables. So these variables, the top 2, are variables set to primitive types. Let ABC equals 27 is a variable set to a primitive type number of 27. Let def equal, quote, hello, in quotes, is setting a variable to a primitive type of string. The next one down is setting a variable to a object, an object type. So it's set to multiple things. That's called an array. An array is kind of like a list, but you can use indexing to get to certain points in it. And we're gonna go over that. So don't. I know that sounds scary and weird, but it's okay. And then you can set a variable to a variable, which is what we've done here. So basically, XYZ is set to the variable def, which we set to hello, and then bar is set to foo, which is the array. And then the last one is set, or indexing, right? So bar of position 0 is set to 200. It's setting the first element of the array to 200. So foo, well, okay. We're setting bar equal to foo, which means that bar is now functionally equal to 45, 35, 25. And then we're setting the first element of bar to 200. Arrays start at 0. Let's start at 1. Arrays start at 0. And we're setting that first element to 200, so now it'll be 200, 35, 25. What does that mean for in memory? ABC is set to 27, def is set to hello, XYZ is set to hello, and then it's just showing that the other two are set to an instance of that array. Okay, let versus constant. This is kind of what I was going over back there. You can see it on table 8.1. Let is pretty much always going to work. Const won't work in several situations. Once you set a variable, a constant variable, you cannot change it. So those first two examples are setting ABC to 27, then trying to set ABC to a different value. It's not going to work. Same thing with the next two down. It's just setting that message and then trying to set it to something else. And even that third one where it's setting it to the same thing, it's gonna break, because if it sees that const there, it's set that first time. Anytime you try to reset it, break. With the exception of an array or a property. So, if you have an array set as a constant, you can set the elements of that array to something else and be fine. If you tried to set that array to something else, it would error. So where we have the foo there, and it's got the 3 values, if you had where it was like foo equals 1, 2, 3 after that, it's going to break. And then the second one is actually an object. Objects can contain properties. In this case, we're creating an object of person, and that person has a name of Randy. And you can reset properties of an object if it's a constant. But like the other ones, if you try to reset what that constant is, it's going to break. And we're going to go over constants next week. So just kind of keep that in mind. All right, built-in objects. So JavaScript has a bunch of built-in stuff so that you don't have to build them yourselves. Really neat. It's got objects, which we just talked about, functions, which we're about to, booleans, which again, yes, no, true, false, 1, 0, errors, which is like an error message, numbers, math, which is a mathematical expression. So, if you go back all the way to like assembly language, which is like the way that computers used to be built back in the day, and if you go very, very deeply, are still built, you have to build out what math stuff means. So what plus means and minus means. JavaScript has that built in. Same thing with dates. Same thing with strings, which are your text. And then regex. So those mean regular expressions. They are ways of basically validating text patterns. We use them to check for things like passwords containing a capital letter, this many characters, and a special character. And then you can also affect parts of the browser. So document is your HTML document, console is again that inspector console, and then window is the window itself. So the example here is setting declaring a variable called def. So that let is declaring, def equals, and then new date. And if you don't put anything in there for date, it's going to default to the current date. And then taking that and setting another variable, declaring another variable called ABC, and then taking that date object and turning it into a string. So instead of a date, now it is text. Okay. All right. Concatenation. And also at this point, before I move on to this, I realize that this is a long lecture. So this is a good point for a pause. If you need to come back to it, come back. But we're getting into JavaScript here, and these foundations are so important. So break it up into pieces that you can deal with. Don't get overwhelmed, and then just come back to it when you can, okay? Okay, so now we're going to talk about concatenation. Those words there are certainly words. Instead of saying to combine string literals together using variables, what that means is you can take two strings, so two sets of text, and mush them together to create a new thing of text. There's also, you can do this using template literals, but for the most part, we use concatenation. So what does that mean realistically? So let's look at this example to our right here. So we have a constant set to, a constant of country set to France. And then remember, since it's a constant, you can't ever change what that country is set to, okay? And then we have a constant of city set to a string of Paris. And then we have another one, a constant of population, set not to a string, but a number, 67. And then we have another one, constant of count, which is set to another number of 2. And then what they're doing here next to it is they're creating a message, or creating a variable called message, right? And the way that they're doing that is saying let this variable called message, set it equal to the variable city, so that's going to be Paris, plus this other string of, you got to remember your spaces in there, space is the capital of space and your quotation marks plus country. So what that's going to say is Paris is the capital of France. So they've built this whole new sentence using the variables already there. And then also, if you use the plus equals, that's like saying take the original and then add to the end of it. We used that in our iterators last class, where we had, I plus plus or plus equals. So then they're saying to that string that we just built, add to it space population of, then add in the country is, and then set it to the population of, or the variable population. Notice that they are not setting population to a string. Population is set to a number, but since JavaScript is dynamically typed, if you tell it to output that as a string, that's fine. So what you ultimately end up with down here, if you look down towards the bottom where it says console log message, is Paris is the capital of France, population of France is 67. And then what they've done down below that is they have another message variable, message2, and they've set it to population plus count. That's just a math. Remember how I was talking about that math objects are built in? It's saying add population plus count 67 plus 2. And then down at the very bottom it's saying, you know, write what that is in the console, 69. There you go. So in addition to the plus equals as being like a take this and then add to it, like keep the original and then add to the back of it, there are other things called conditionals. You don't need to know that they're called conditionals, just know what the operators are. So we're going to look at these for our function, for our statements, like if statements, for, switch, case, those kind of statements that are coming up. But basically we are using parentheses to take a statement and test and see if it is true. And then if it is true, do the things contained in the bracket blocks. And then you can use if else to add on extra statements with it, or just else to end it. But the big thing is these at the very last sentence, the expected comparator operators. So we have less than, greater than, equals to. Notice that there are two equal signs there. You have to use the two equal signs because you use just the single equal signs to set stuff to stuff, right? So you declare a variable, one equal, and then variable. And then the next one over after the two equal sign is less than or equal to. The next one is greater than or equal to. The exclamation point is not. So if it is not set to or not equal to. And then the last one is an equals, but also not, it doesn't take into account sorry. It doesn't take into account certain properties of it. So it's a more strict equal sign. Okay. So what we have here is a switch statement. And then we also have an if and else statement in here. So like I said before, we are using those conditionals to test if a thing is true. And then if that thing is true, do a thing. These are just two separate ways to do it. So in the first one, we have a switch statement. So what it's saying is with the variable art type, if it is set to PT, do this thing. And then stop. Break means stop. Stop doing the things. If it is set to SC, then output sculpture. And then break, stop doing the thing. And then if it's not set to either PT or SC, if it's set to anything else, set it to other. So switch statements are really great if you don't want to do a bunch of if-else statements, but you know that there are certain ways that your things are going to equal. Switch statements are great for things like days of the week because you know it's going to be, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So you can make cases for all of those. If-else statements are things that you don't necessarily know what the thing is set to, but you want to check it against a couple of things. So in the second one, it is the exact same thing in terms of output as a switch statement. So both are valid. It's just whichever one you feel more comfortable using. So it's saying if the art type is equal to PT, because remember we have our double equal sign, then the brackets, output painting. And instead of having break, we just end it with a semicolon because the ending bracket is saying, okay, stop doing the thing. And then we use an else if, so it's saying if it's this, do this thing, but if it's not that and it is this thing, this other thing, do that thing. So if it's PT, do this thing, but if it's not and it is SC, set it to sculpture. Otherwise, which is that final else, set it to other. So again, it's checking set if it's set to PT. If not, it'll go down to the next one. Check if it's set to SC. If it's not, then it'll go down to the next one, and then the output is other. So that final if is final else is your default statement. And this will become much more concrete when we do our lab. So these are basically breaking down what I went over in a different way. It's kind of like a pseudocode. So it's saying, it's a one line instead of a pseudocode. So that it's just as valid. It's a little bit more confusing to read. So what it's saying is foo equals, and then you have your condition. So if y equals 4, then if it is true, do the string y equals 4. If it is not, do y is not 4. So looking at the next one down, we're declaring a variable of tip, setting it equal to a condition. Is it a large group? Which is another variable. And then the question sign. And then if it's true, set the tip to 0.25. If it is not true, set the tip to 1.5. Last one, same thing. With the price. But this has two conditional ternary operators in it. So it's setting declaring a variable called price, and then setting it equal to, is it a child? If so, set it to 5. If it's not a child, is it a senior? If so, set it to 7. If it's not either of those, set it to 9. So it's the exact same thing as an if else statement. This is just a cool thing to know. You don't really need to memorize it, but everything in JavaScript has an inherent Boolean value. So everything in there is either true or false. So it's said to be truthy if it translates to true, falsy if it translates to false. All values in JavaScript are truthy with the exception of false, which you can't be true and false at the same time. Null, which remember is always set to null. Nothing there. What that is with the double quotes with nothing in the middle is setting it basically to a null value. Same thing with the sequel or the single quotes. So it's just setting that blank value. 0 NaN means not a number, and then undefined. Okay, so we've seen if-else statements, switch statements, and then the conditional operators. Now we're going to look at while and for loops. So what while means is while this statement that is in between the parentheses is true, do something, and then stop it when it's not true. Okay? So, here is an example of it. And it's just the differences between the top and the bottom is how it is, how it's just laid out. Both are valid. But yeah. So it's saying set count to 0, and while count is less than 10, do this thing, and then add 1 to count. That's what count plus plus means. Add 1 to it. So that first time around, it's going to say, okay, well, count is 0. 0 is less than 10. So we're going to do the thing, and then we're going to add to count. So now count is set to 1. It's going to run again until it gets up to 9, because 10 is not less than 10. 10 is equal to 10. And then it's going to stop. The bottom one is the exact same thing. You're setting your variable count equal to 0, telling it to do the thing. So you have your conditions there, also with your count plus plus, while this thing is true. So it's just whether or not you have the condition before the loop or after the loop. Okay, so for loops, kind of the same, but different. So instead of doing this whole thing of, initializing the loop, setting the condition, setting the control variable in like different lines, a for loop does it in one line. I like for loops a little better because it makes me type less. So we're saying for, and then we have a variable that we're setting. Okay, so for this condition, right? And the condition is within the parentheses. So we start the condition with the initialization. So we're saying for this condition, we're going to create a variable called I and set it to 0. And then we're going to do this as long as I is less than 10. And then every time we do this, we're going to add 1 to I. And you use semicolons to break up the statements, the components. Okay? So we have the initialization. So set whatever variable you're going to use. I is standard. I don't know why. Don't ask me why, but I is standard. We're going to set it to whatever number. And then we're going to use the condition of, well, this is less than, greater than, not equal to, whatever. And then the post loop is each time we do this, also do this thing. So it is the exact same functional thing as the while loop that we looked at, just in that one condition on one line. Here's something that's really important. You can get infinite loops. Basically what that means is if you set your conditional variable wrong or your iterator wrong or something, and it's never going to hit that value to stop your loop, it's going to go forever. It's going to go forever until your program crashes. So some browsers have it built in to stop scripts after a certain amount of time to stop it. If you're doing something like PHP or C# or something not browser based, then you will crash whatever software you're using. But you can also lock up your browser window. So it's really important to make sure that with your statements in there, it is going to be true at some point. One way to mitigate this, and this is not something we're going to be really covering in this class, but you can use a try-catch statement. And what that means is try this thing. If it works, great. If it doesn't work, catch it, stop what it's doing, and throw up this error. So if you are not sure that your thing is going to work, those try-catch statements, it's just good practice. It's best practice to put those in there so that you're not getting those infinite loops. And this also means that since, like we saw earlier, if you have an error in there, the JavaScript stops at that line. If you use a JavaScript try-catch, it will go past that. Okay, we just got a little bit more. Again, this is a lot. So if you need to take a break, right now is a good spot to take a break. Take a pause, get some water, come back, do some stretches. But we're going to talk about some data structures here. Specifically, we're just going to talk about arrays, and then next week we're going to talk about objects. But an array is something that you are going to use in programming a lot. There are two ways to define it. The first one is array literal, which basically means you declare your variable, and then you use the square brackets to set the values of your array. So that's what's in the first one. It's got the constant variable name, and then the square brackets, the value 1, value 2, etc., etc., etc. The second one is to use the array constructor, which means that you have to tell that it's making an array. The first one, if you use those square brackets, it knows it's making an array. The second one doesn't use the square brackets, so you have to tell the program that, oh, okay, we're making an array. So the way that you do that is you declare your variable, have your name equals to new, means make a new array. So make a new array, and then you've got your values in parentheses. Both of them, the values are separated by commas, not semicolons, commas. So here's an example of an array. Let me see if we can get this to where y'all can actually see it. Okay. Basically, this is a version of the example 8.6 from your book. So there are some arrays here. The first one is an array with the name of years with the values of 1855, 1648, and 1420. If you look to the right, you can see the how the index works. So like I said, starts at 0. So for years, your first value in your array is an index of 0. It's going to be 1855. Your index of 1 is actually your second value, which is 1648, and then your index of 2 is your third value, so on, so on, so on. So if we look at this this array that's set to countries, your index of 0 would be Canada, index of 1 would be France, 2 of Germany, etc., etc., etc. You can also have multi-dimensional arrays. So what that means is that you can have arrays within arrays. So this is functionally an array called 2 weeks that contains 2 arrays. The first one contains Monday through Friday. The second one then also contains Monday through Friday. So the way that you index these, and it doesn't have it in there, is that you would do, let's say you wanted the first week, or so this top one, and you wanted Wednesday. So it's the first array. So you would have index 2 weeks. Here, where's my text box? There's my text box. Okay, so for the Wednesday of the first week, you would say 2 weeks 0. So that's this first line here. 2. Good. Oh. There you go. Because again, starts at 0. So if you wanted Monday, it'd be 0, 0, or Tuesday would be 0, 1, 0, 3. If you've worked with matrices in math, arrays are basically matrices, just flat ones. You can also use different data types within an array, so they don't all have to be strings or all numbers or all whatever. So like this last one here, set to a number, string, a boolean, and then another number. Okay. So you can use an array to iterate through a loop. Sorry, you can use a loop to iterate through an array. What that means is that you can use a loop to step through an array. So hit every index in there. So iterating through an array looks like this. So for setting a variable of year of years. So for every year in the array years, write the year. That is the equivalent of using a for loop of, for setting I to 0. And then the way you get the length of an array is the array.length. So as long as I is less than the length of the array, and then add 1 each time, let the variable year equal years, which is our array, at the value of I. So on the first loop, I is set to 0 everywhere. And then write that out in the console. So much easier, right? Doesn't matter what you name your let in here. So let YR or year. You could have written out year. You could have written, let dog of years. You just have to set a variable that holds that value. Okay. Here's the cool thing. We used to have to, if you wanted to take a value out of an array and set it to its own variable, you would have to set the array, which is what they've done at the top, league, and is set to Liverpool, Man City, Arsenal, and Chelsea. Manchester City, by the way. These are, looks like rugby leagues. So, if you're wanting to set variables to the values of that array, what you had to do was explicitly set it to the index of that array. So that's what's example here. So let first equal the league at index 0, which would be Liverpool. Let second equal league at index 1, which would be Manchester. Let third, blah, blah, blah. You can use array destructuring now, which just uses a single line. So let first, second, third equal league. So what that's saying is let these variables, first, second, and third, equal the first, second, and third index of league. The position is set by the position before the comma. So this is index 0, this is index 1, this is index 2. Same thing. Alright, functions are the last thing we are going to go through because they are incredibly important for our lab. Let me just kind of scooch. There we go. So functions are basically saying, do this thing. They you have to use the word function to call them, to set them. You can use parameters in them, or you don't have to. And they don't have to return something. They can just do what they need to do within them. And you don't have to set the parameter types in there. So I know I keep going back to C#, but that's the other language that I heavily program in. In C#, if you are setting a function parameters, you have to put in like int whatever the parameter is, or string whatever the parameter is. You don't have to do that here. Okay, so how do you declare a function? Well, what you do is you have to have the word function. Oops, didn't slide. There we go. So you have to have the word function, and then you have the name of your function, and then these are what the parameters are. Okay, so these are what you're passing through into the function. And then this is what the function is doing. It's returning a value of price times quantity. So we're going to see this in our lab, but it's saying this function is named subtotal. It's taking these parameters of price and quantity, and then what it's doing is returning, so outputting, the value of price times quantity. If you have parameters in there, when you're passing them through, you have to have them in your function. So you've declared your function, that's great. But how do you actually do anything with it? The way that you do that is you use you call the function. Call or invoke, whatever. When I started programming, the hardest thing for me to remember was that I had to call the function. Because if you just declare it, it just sits there. You have to actually tell it to do the thing. So what it's done here is it's created a variable called result and set it equal to the function subtotal, because we've already declared the function here. And then our price is going to be 10, and then our quantity is going to be 2. This is what I mean when I say if you declare a function with parameters, when you call that function, it has to have those in there. So this one has 2 parameters. You have to have 2 in there when you call it. Otherwise, it's going to error. So let's kind of work out what this is, right? So for this one, result, we're doing the function subtotal. We're passing through 10 and 2. We're going to return 10 times 2. So we're going to set result to 20. Function expressions. Get rid of this thing again. Okay. So remember how way back I said that functions were objects and can be treated as such? The way that you do that is using like a function expression. So what it's done here is declares your function, calculate subtotal. It's a function, or sorry, declare constant of calculate subtotal. Use a function with price and quantity. If you do it this way, it's called an anonymous function expression, and you don't actually have to name the function in it. And then invokes the function saying let result equal calculate subtotal, which is our constant, using the function with our 2 parameters. So it's just using a function as an object within another variable. So look at this one. This is a constant called warn with a function of a parameter message saying make an alert with the message, and then invokes that function. So we call warm, and then this doesn't return anything. What's going to happen is it's going to make an alert, so a pop-up window with the message. This doesn't return anything. Okay, remember how I was talking about you have to have it in there? This is what I mean. So we have this code block here. So we have a function called foo. We have two parameters, a and b, and then it's going to return a plus b. And then we're creating a variable called bar and setting it to foo of 3. Notice there is not a comma and then another value. So if that happens, it's going to error and give us a nan, not a number. It's going to stop because it's done. The way around that is to specify default parameters. So what you do is when you're creating your first the function, you can set your parameters as a default, and then if they only return one of them, then it goes to the other default. So in this case, it's the same function, foo. It's going to take a parameter, or two parameters. The first one, if it's not there, will, well, in this case, it's going to always overwrite this a. So the a is set default to 10, and then second parameter b is set default to 0, and then it's going to return a plus b. So if we're setting bar to foo of 3, that's that first one. So it's going to overwrite that a, and it will be 3 plus 0. Sorry, 3 plus 0, and it will be set to set equal to 3. Make sense? Okay. So that is actually the end of our lecture for this week. I know it was a lot, but you guys are doing great with it. Just go back and watch sections you need as needed. Make sure to look at your book for examples, and then I will try to break down the lab assignment in a way that goes over these and reinforces them. But that is it for this week. Next week we're going to be going over some more about functions and then some more about objects. Have a great rest of your week. There is no midterm. Just remember that since this is a like project competency based class, I don't really feel that, doing a separate project for a midterm is necessary, or doing a test, because with programming, you need to know how to Google. You don't need to know how to remember. You need to know how things function and logic works, but I'm not going to make you memorize stuff. So have a great rest of your week. Always reach out if you need something. Thanks. Bye.